Hello everyone. Today I want to just cover a quick section on Chapter 2 and talk about cost indexing and power sizing. Just to give you a quick example on that and how that works. These are just two ways of estimating future costs or past costs. If we look at cost indexing, it's based off of the Consumer Price Index. It's a unitless number that can be used to calculate the cost today based on some cost of something in the past. You can also work this in the reverse order also. So as long as we know one of these four values, we can always find the third, right? We can just use simple algebra and determine one of the other values. Typically, though, we know some past value. We're trying to find some future value, and we know the past cost index value and then the current index value. And there's different sources, as you will see in the notes and everything, on where to find these index values. But let's look at a problem just doing this cost indexing. Here's an example. We need to estimate the cost of a new pump. And we bought this pump 10 years ago for $550, and the cost index 10 years ago was $110. Today the cost index is 200, and we need to know what is today's material cost, or what is the cost of this new pump. Okay, so we know that we have the cost at time A is equal to the index at time A and it's over the cost at time B over the index at time B. And here we will say that A time A equals 10 years ago, and time B is equal to today. Okay, so if we look at this, we know, starting out, go back to the red, we know the cost at time A is this $550. And our index 10 years ago was 110. Now let's look at the today costs, and we know today we don't know what the cost is, but we know the index for today is 200. So now we should be able to solve for x. Right? We can solve for x. And we can do that just by simply cross multiplying. So we would have $550 times $200. And you see that these are unitless. On both sides we have units over dollars of dollars, and then cost index over cost index equals, oops, this isn't $200, sorry. That's just 200 is the cost index, and then we have 110 times x. And x equals $550 times 200 is our cost index divided by 110, which is our cost index. And if you work that out, this will be units of dollars of 1,000. Okay, so remember in doing all these problems also that you need to write your givens, your what you're trying to find. In this case, we're trying to find our time B, our cost in time B. And what we're given is all the indexes and the dollar values. So that's how you use cost indexing. A lot of times, though, we can use these in conjunction with something else called the power sizing model, where we're trying to make scale up or scale down something. And we're going to do a problem where we scale something up. So it gives us at a different size. We may know something that we bought smaller maybe years ago, and now we want to buy something new and bigger. How do we do that estimate? We use something called this power sizing model, where we have our cost of the equipment of A divided by the cost of equipment B, and maybe B is what we're trying to find, this new piece of equipment. And then we have the size, or the capacity of the equipment of A divided by the capacity of equipment B times this exponent. And this is called the power sizing exponent. We call it the PSE, you will see sometimes, power sizing exponent. Okay, so if we know any of these, if we know all of these values except for one of them, we should be able to find any of the other ones. Okay, so let's look at the same example that we just did, where we already solved the first part, in part for the cost indexing. We found that today's cost of the same size pump equaled $1,000. We solved that in that last problem. But now we want to take that old pump. That old pump was 10 horsepower, and now we want to buy a new one that's 15 horsepower. And we know that the power sizing exponent is 0.75. What is the cost of this pump today? We know if it was the same size pump, the same 10 horsepower pump, it would cost $1,000. But we don't know what it is based on this new size. And if we remember our equation, we had cost of pump A, in our case, we'll say the 10 horsepower divided by the cost of pump B, or a 15 horsepower one, right? We know those costs. We don't know this. This one's an unknown. That's what we want to find. And if we look at that, we can multiply it, or set it equal to the size of pump 10 horsepower over size pump 15 horsepower, right? They're the same. And then to our exponent, our power sizing exponent. And it's always important to know that we keep our numerators and denominators the same, so we keep that same relationship. Okay. Let's see. Somehow I missed. So if we look real quickly, we keep this same relationship here. This and this are the same, and then we see our denominators are the same as far as they're both relating to the horsepower. Okay, let's go back here, and now let's put in our values. So the cost of pump A was our original cost today of a 10 horsepower pump. We solved from this first part up here, and we know that that is $1,000. We don't know this value here is what we're looking for, but we do know that it equals to our 10 horsepowers divided by 15 horsepower, 2.75. And again, if we cross multiply this, right, we can figure this out. We have $1,000. is equal to x, and it's divided by 10 over 15 to the 0.75. And we will see that x will equal an estimated $1,355. And if we look at this, it makes sense, right? We would think that a new pump would cost more, a larger pump would cost more, which is showing that, you know, a 10 horsepower pump today is $1,000 and a 15 horsepower pump is $1,355. So that seems to make sense. Also, we know that the original pump, the 10 horsepower pump, was $550 10 years ago. Today it's $1,000. So that all seems to make sense. Okay. One last little bit of information is sometimes this power sizing exponent might not be known, and you'll want to do something called using the law of logs. And I'll have you look that up. You can find information on that online on how to solve the law of logs if you don't remember how to do that from algebra. Okay? If you have any questions, please get a hold of me, and I hope this little video was helpful. Have a great day.